Today I'll be going over 10.4, which is find probability of disjoint and overlapping events. The union of A and B would mean anything that happens in A or B. So if it occurs in A or occurs in B, that's the union. And the intersection of A and B would be where it occurs in both. So it's in a Venn diagram, it would be the middle section where they overlap. Some vocab, we have the word overlapping, and that means when two events have one or more outcomes in common. So it's like the intersection, that center part that overlaps. And disjoint or mutually exclusive, those two mean the same thing, and that's when two events have no outcomes in common. So if we drew a Venn diagram, it would look like the one below, where they don't overlap at all and they're just separate. To find the probability of compound events, if A and B are any two events, then the probability of A or B is probability of A plus probability of B minus probability of A and B. So probability of A would be this section here, and probability of B would be this section here. And if you notice, the part in the middle, the intersection, is repeated. So that's why we have to subtract that so it doesn't get counted twice. And if A and B are disjoint, then the probability of A or B is probability of A plus probability of B. So since they're already separate, we can just add them together and we don't have to worry about the part where they overlap. Okay, so in numbers 1 and 2, we want to find probability of A or B given that they are disjoint. So we're going to be using this equation here. So probability of A or B is going to equal probability of A, which is 0.55, plus probability of B, which is 0.2. So probability of A or B is going to be 0.75. Next, we have probability of A is 2/5 and probability of B is 3/5. So again, we can just plug that into the equation, and that'll be 2/5 plus 3/5, which is 1. Okay, for numbers 3 and 4, we want to find the indicated probability, and we're just going to assume that they're not disjoint. So we're going to be using the first equation. So probability of A or B, which is 0.7, is equal to probability of A plus probability of B minus probability of A and B. So we can add 0.6 and 0.2, and that'll be 0.8. And you can think of probability of A and B as like x. So in order to isolate it, we have to first subtract 0.8 and then divide by a -1. So we get -0.1 equals negative probability of A and B. And we can divide by a -1. So then we get probability of A and B equals 0.1. And you can check that you're doing this correctly by looking at the number that it equals. So a probability can never equal a negative number. So if you get a negative answer, then you'll want to double check your work. Okay, number 4, we're looking for probability of A or B. We're given that probability of A is 0.46, probability of B is 0.37, and probability of A and B is 0.31. So you'll get 0.52. Okay, next is about cards. A card is randomly selected from a standard deck of 52 cards. Find the probability of drawing the given card. So only one card is being drawn. Number 5, we want the card to be a king and a diamond. So there are 52 cards total, and we want both to be true. So in a deck of cards, only one card is a king and a diamond. So it's going to be 1 out of 52. And as a decimal, that'll be 0.0192. Next, we want the card to be a spade or a club. So in a deck of 52 cards, there are 13 spades. And the word or means we're going to add. In a deck of cards, there are 13 clubs. So 13 over 52 plus 13 over 52 is 26 over 52, which is 0.5. And number 7, we want to pick one card that is a 6 and a face card. But that's not possible. Like, there are no cards in the deck that are both 6 and a face card. So that would be 0. Okay, next we have complements. So the complement is are the outcomes that are not an A. So the symbol is like with a bar over the A. So probability of not A is 1 minus probability of A. Since if we add up all of the different probabilities, that should add up to 1, because there's 100% chance of everything happening. So if we do 1 minus the probability of A happening, we'll find the probability of A not happening. So for 8 and 9, we want to find probability of not A. So the setup is going to be probability of A bar equals 1 minus 0.5. So that's going to be 0.5. Then for number 9, we're given that probability of A is 1/3. So probability of not A is going to be 1 minus 1/3, which is 2/3. Okay, next here we have a table that shows all of the different ways two dice can be rolled, and we want to find the probability of the given event. So if we look at the table, this one means like you roll a 1 for the first dice and a 1 for the second one. And there are 36 options here, so that's going to be our denominator. Okay, so it says the sum is not 7. So there's two ways you can do this. You can count the ways that it doesn't add up to 7, or you can count the ways that it does add to 7 and subtract it from 1. So I'm going to do it that way because I feel like there's a little less to count. So these add up to 7 here, and there are 6 of them. So 1 minus 6 over 36 will tell me the probability of picking or of rolling dice that won't be 7. So that'll get you 5 over 6 or 0.833. Okay, number 11, the sum is less than 8 or greater than 11. Okay, so we see the word or. That means we're going to be adding two fractions. The possible outcomes is 36 for both. In the first one, we're looking for when the sum is less than 8. So all of these are less than 8. So there's 21 of those options. And we also have to find the ones where the sum is greater than 11. So that's only this one, because that adds up to 12 and everything else is less than 11. So our equation would be 21 over 36 plus 1 over 36, which is 22 over 36, or 11 over 18, or 0.611.